now in class 11th, I have the topic energy. This is the very important topic nowadays. This energy is this has been derived from the Greek word which means the ability of doing work. That is called the energy. The ability of doing work is called energy. Now energy, then how to measure to this one? That this is always measured from its standard position to some the present position of the object. Kinds of energy. There are a number of energies, and our universe is full of energies. Like we are having this number one, the mechanical energy. Number two, the solar energy. You have heard the name of this solar energy. Wind energy. Heat energy. Electrical energy. Electrical energy. The atomic energy, molecular energy, etc. There are so many energy. Our universe is full of energy. Our universe is full of energies. It is having a number of energies. So these energies are being converted into one form to another form, or the energy of the whole of the universe always remains the constant. That I will tell you when I will teach you about this the conservation of the energy. So now in this topic here, we are concerned only with the mechanical energy. The mechanical work means that suppose if you push or pull the object, if you stretch the wire, if you increase the length of the wire, or just you are moving, or just you change the position of the object, then because of that we are having the energy. That is called the mechanical energy. So now here we are concerned with the mechanical energy. Mechanical energy. The ability of doing mechanical work is called mechanical energy. Mechanical energy. Generally, this kind of energy is of this energy is of two kinds. One, the potential energy, and second, the kinetic energy. Mechanical energy is of two kinds. Number one, the potential energy, and number two, the kinetic energy. The kinetic energy. What happens in mechanical? Either we are changing the configuration of the object, or the object is being moving with some velocity in certain direction, then we are having this kinetic energy. So first we are taking the potential energy. Potential energy. Potential energy. The energy possessed by body due to its configuration is called potential energy. Is called potential energy. Configuration means any kind of this one. I just you push the body, pull the body, stretch the body, or suppose you are changing the position of the body from one place to another place, or you are carrying the body in the upward direction, and some body is allowed to fall vertically downward. Then this is all the configuration. So this energy. We can have it is equal to the work done to bring the body from standard position to some present position. Standard position is taken the point where the body have no ability to do the work. So this happens when the body is at infinity, because at infinity the work is not there is no ability of doing the work. So what we are having, that suppose we are having the gravitational field and body is suppose at infinity, then there will be the no gravitational force. So there will be no work done by the gravity. It means that the position that is at the infinity, this will be taken as the standard position. Similarly, if suppose we are having the two charged particles and they are brought away from each other, quite away from each other, so that the electric force between them is zero, then the work done will be equal to zero. So there will be the no energy. So the standard position is always taken where the energy of the body is zero, or the body have no ability of doing the work. the standard position means the position where the body have no ability of doing work. So generally this is taken at infinity. So generally the standard position is taken at infinity. It means what? That suppose we are having this is the standard position, this is now at infinity, and suppose the body is brought here. This is now suppose the present position. This is now suppose P, the present position. This is the standard position. Then let the work is being the forces in this way. The body is brought in this direction. This is the motion, this is the body that is brought to this position P from this infinity. This is the, so definitely we have to work against this force. And let us, we are having some displacement here. This is now your dr. Then definitely the work done in this small segment that will be equal to F dot dr. And this the work done by against this force will be minus F dot dr. Let a body is brought from infinity to point P against the force F. So some work will be done against this force. So work done against force. Work done against the force. This W is equal to a minus sign integration infinity to, suppose this is now you are given this situation, this distance is to be now R1, infinity to R, and then this F dot dr. So this will be the potential energy. It is the potential energy. It is the potential energy. Potential energy. So what we are having, U equal to minus infinity to R. This is now your F dot dr. Now if you know the nature of the force, then you can find the work done, you can find the potential energy of this one. Suppose you are having the body which is taken to be at infinity, where the ability of the doing work is zero, then definitely there will be no energy at all. So that is the standard one. So from that standard position, we are bringing the body to the present position. So what is work done is going from infinity to the point P or the point of observation. That is called the potential energy. This is what the configuration of the body. Suppose all the physical systems are in the normal conditions, so they are having the minimum energy. And then suppose you are displacing to them, or you are just pulling or pushing them, then definitely you are changing the configuration. So what? That the work will be done against to that the configuration that we are having at the infinity. It means that this is always the negative integral, line integral of the force. Thus, potential energy is equal to the negative line integration of force. So this is equal to minus. So by having to this one, we can have that this potential energy will be positive, negative, but generally the potential energy is negative. So the potential energy may be positive and negative. If suppose the body is brought against this force, then this will be the negative one. And if it is suppose in the direction of the force, then this potential energy will be positive one. So whenever we are having this potential energy, it may be the positive or negative. And suppose there is no work done at all, then the potential energy will be zero. Positive, negative, and zero. So now this is about the potential energy, how to find it, and you can have this. You will study in the next chapters that how to find this potential energy with the help when the force is given to you. Now we will talk about this kinetic energy. Kinetic energy. As the name suggests, this is due to the motion of the body. The energy due to the motion of body is called kinetic energy. Kinetic. So this is the equal to the work done when the body is brought from the moving situation to the at the rest. it is equal to the work done when body is brought to rest position from its moving position. Let a body of mass m is moving with velocity v. Then what happens is, suppose this is now a body, this is moving with velocity. Suppose we take this velocity v1. This is now velocity v. This is now body that is moving in this direction, and now suppose n force is applied on it in the opposite direction, so that the body comes rest after moving a distance x. Let F equal to force applied in opposite direction of velocity, then definitely the body will retard. So now acceleration in the body, the acceleration A, that is equal to minus F upon v. This negative is why that this force is opposite to this velocity, so this will oppose. This means the velocity will increase, will decrease. So there will be the retardation of this object. So here the body is at rest. So the final velocity is to be here. This is now equal to 0. So now this b dash, this we take equal to 0. So now what we have? Now using third equation of motion. What is here? This is now v square equal to u square plus 2as. Now here we are having this u, this is equal to v, and this, now here the final velocity, that is we are having this one. So I think I must take it. This v equal to v dash, this is equal to now 0. This is now final velocity. This is initial velocity, u equal to v. So, and this a, that is equal to minus f upon m. So this is velocity is to be now 0. This is now your minus This is now plus b square minus 2. This is now f upon m, and this is now your x. Now here this s equal to x. I think this will be confusing to this one. Let a body of mass m is moving with velocity v1. We take it to be now v1. This is now better. This is now v1, and then this is v2. This is equal to 0. So now we have this u equal to v1. And this is your V2. This is equal to now 0. V2 is equal to 0. So this is what? V equal to V2 equal to 0. So now we use to this one. This is now suppose V1 is square. And this is, suppose this velocity is not to be 0 here. This is now your V2. V2 is square. So this V is equal to V2, U equal to V1, V equal to V2, S equal to so much, and A equal to minus F upon M. Then we are having this. So we can have this 2 Fx upon M equal to V1 square minus V2 square. So Fx equal to half M. So this Fx is equal to half m v half m, and this is now your v1 square minus v2 square. And if V1 equal to V and V2 equal to 0, then Fx equal to half mv square. If we take this condition, then this Fx equal to work done, this is equal to work done, this is equal to half mv square, where this W is equal to Fx, then this work done is equal to the kinetic energy. It is the kinetic energy. So this kinetic energy, this is equal to W, and this kinetic energy equal to half mv square. This is so much. Now you can see from here that this kinetic energy depends upon, number one, kinetic energy is proportional to m. So as we increase the mass, the kinetic energy will increase. So if we are having a graph like this is suppose we take the kinetic energy here, and here we take the mass, then definitely this kinetic energy will be like this. So this shows that this kinetic energy is proportional to m. Kinetic energy will increase with the increase of mass. Now this kinetic energy, we can have this kinetic energy Now second, kinetic energy is proportional to V square. So as this kinetic energies we are having to this one, this is now 0, this we have the kinetic energy, no, this is now velocity, this is now velocity. Here we are having the velocity on this side and on this side also, and this we take here the kinetic energy. Then you can see that this will come out to be like this. It is in the form of parabola. So whether this velocity is negative or this is now positive, then kinetic energy is always positive. The velocity may be positive or negative, but kinetic energy is always positive. It means that kinetic energy cannot be negative. This is always 0. This is always positive. So if we are adding to this one, if suppose the velocity is 2 times, the kinetic energy will be 4 times. The velocity is 3 times, then this will be now 9 times. So we are having this. Now this is now suppose 1 and this equal to 2, then this is now your b1 square upon b2 square. We are having this formula and this one also, and here we are having this one. So mass is never negative, mass is always positive. Because of that the kinetic energy cannot be negative. The velocity may be negative, but because of the square term this will be positive. It means that the kinetic energy is always positive. Since m is not equal to negative, the velocity may be positive or negative, but because of a square this will be always positive. So kinetic energy due to square of V, the kinetic energy is always positive. While the potential energy may be the negative or positive, but this will be always the positive. So this is what that the kinetic energy depends upon the mass of the body and its energy and its velocity. So kinetic energy is always positive. Here you can see that this kinetic energy graph between the kinetic energy and that of this velocity. This is in the form of a parabola. So this is shows the variation of kinetic energy with the velocity. So thank you very much.